Hi. In this problem, we are going to look at a old Putnam exam question. This is Putnam 1986, and the question is find the units digit of 10 to the power 20,000 by 10 to the power 100 plus 3 and the GIF of that. Basically, the greatest integer function less than equal to this, right? So now this problem looks daunting right now, but we'll think of ways in which we can reduce the problem and solve it. First thing I want you to realize here is that this identity is valid. This is a common identity. If you divide x power n minus y power n by x minus y, you should get x power n minus 1 plus x power n minus 2y plus x power n minus 3y square and so on till x into y power n minus 2 plus y power n minus 1. So basically every term on the right hand side has degree n minus 1, which is what comes when you divide x power n minus y power n by x minus y. Now, why am I doing this? Because I ultimately want to simplify this in this way. So if I say x is equal to 10 power 100 and y is equal to minus 3, I can put that here and it will become an n is equal to 200 basically. Then I should get 10 power 100 power 200 minus, instead of y I have to put minus 3 power 200 divided by 10 power 100 minus minus 3. So I'm getting basically 10 power 20,000 and this is minus 3 power 200, so it is minus 3 power 200 divided by 10 power 100 plus 3, right? Why am I doing that? Because now I'm getting the denominator at least matches. The top part also matches almost with an extra term, right? So this should be equal to, if I use this identity, this should be equal to something like 10 power 100 power 199 plus so on so on. Let's write the second last term here. It will be 10 power 100 multiplied by minus 3 power 198 and the last term will be minus 3 power 199, right? Now, if you think about it clearly, look at all the terms here. All the terms here have 10 power 100 in high powers, right? So obviously the term here, the number here ends in 0, ends in 0. Every term ends in 0 till this term. This term also ends in 0, right? Correct? Because there is a 10 power 100 here. But this term doesn't end in 0, right? Okay, so basically, if I have to find the units digit of something, then I need to care about the units digit. So if it ends in 0, all these terms end in 0. So we can say that the units digit of this expression should be equal to the units digit of this rate. So units digit here is equal to the units digit of this expression, correct? Great. So we have that result at least. We can find the units digit of minus 3 power 199 and I will do that later. But for now what I have realized here is that 10 power 20,000 minus 3 power 200 by 10 power 100 plus 3 has the same units digit as minus 3 power 199, right? So that is an important idea here. Also, we have not done the GIF part yet. Ultimately, I have to find units digit of 10 power 20,000 by 10 power 100 plus 3 and GIF of that, right? Correct. So what we know is that this is an integer. This is an integer because all the terms that were coming were integers, right? So let's call this integer as I. So 10 power 100, 10 power 20,000, 20,000 minus 3 power 200 by 10 power 100 plus 3. Let's call this integer I. Now what I want to say is if I take GIF, both sides will remain same. So GIF of this minus 3 power 200 by 10 power 100 plus 3 is equal to the GIF of I, which is I only, right? Now I split this into two parts. I can split it like this. I can be written as 10 power 20,000 by 10 power 100 plus 3 minus 3 power 200 by 10 power 100 plus 3, right? Now, if you realize this, you can say I plus 3 power 200 by 10 power 100 plus 3 is equal to 10 power 20,000 by 10 power 100 plus 3. Basically, I am breaking apart this thing and writing it like this. If I take GIF on both sides right now, what I'll get is GIF here, GIF is equal to GIF of this thing. And you have to realize that 3 power 200 by 10 power 100 plus 3 is equal to basically 9 power 100 by 10 power 100 plus 3. So obviously this is less than 1, right? 9 power 100 is less than 10 power 100 plus 3. So that is obvious. So this quantity is less than 1. So GIF of some integer plus something less than 1 is going to be same as GIF of I, right? Correct? So what we are saying is the GIF of this number is the same as the GIF of the number that we need, right? We needed units digit of this GIF. So now since this GIF is equal to GIF of 10 power 20,000 minus 3 power 200 by 10 power 100 plus 3, which is our I, we can just focus on the units digit of this, right? We know already that this is an integer. So we don't even need to write the GIF sign because we know that this I is itself an integer. So we just need the units digit of this I, right? And earlier we had seen that it has the same units digit as minus 3 power 199. So ultimately my job is now to find the units digit of minus 3 power 199, right? So let's do that. Minus 3 power 199 will be equivalent to basically minus 3 power 3 multiplied by 3 power 196, but that what I can write it as 3 power 4 power 49, right? So that is equivalent to minus 27 multiplied by 81 power 49. And the reason I took 3 power 4 here is obvious. 81 power 49 will always end in 1, right? 81 power, any power of 81 will end in 1 because its units digit is 1, right? So this ends in 1. So the digit, the units place of this number depends on this minus 27. So it is equivalent to basically minus 27. And minus 27 is equivalent to basically 3 mod 10, right? It's like saying if you do if something is minus 27 mod 10, basically what you are saying is you have say 100 and you subtract minus 27. So that will become 63 or something, 73, right? So we can say minus 27 is 3 mod 10. So the units place, units digit of minus 3 power 199 is 3 because 27 is actually subtracted. So units digit of this is 3, and we know that that means that the units digit of 10 power 20,000 minus 3 power 200 by 10 power 100 plus 3, this which was equal to GIF of 10 power 20,000 by 10 power 100 plus 3, both of them have the same units digit, and units digit is 3. I hope you understand what we have done here. The first step was the binomial identity, which was x power n minus y power n divided by x minus y. We put appropriate values for x, y, and n. After that, we expanded and we realized that we could split the original functions into two parts where we realized that only minus 3 power 199 term matters because all the other terms were ending in zeros. So if I care about the units digit, I only have to worry about the last term in that sequence, right? Once we got that, we also realized that GIF of 10 power 20,000 by 10 power 100 plus 3 was the same as the integer which was equal to 10 power 20,000 minus 3 power 200 by 10 power 100 plus 3. And that integer's units place was simply minus 3 power 199, which we found as ending in 3. Right. So that solves the problem. This was one of the second, it was, I think, the second question or the first question of Putnam 1986. So hopefully you've learned something from this problem, and you will be able to apply modular arithmetic in a similar way when you encounter things like this. Uh, if you like the video, please subscribe to the channel, and I'll see you in the next video.